Sorry about that. Hello, everyone. Welcome to the very last day of National Astronomy Week 2020, night 9. I'm Sandra Voss from the Observatory Science Centre, and I, for one, am very proud to be part of the National Astronomy Week team. If you stay with us to the end of the observing session tonight, you will meet other members of the team who want to say hi and goodbye. Oh my goodness, what a huge success National Astronomy Week has been this year, despite the most difficult of challenges with the pandemic. Yes, it's been very different, but having speakers from all over the UK, then overseas, streamed straight into your home has been quite a bonus. If you've missed any of the sessions, you'll be able to catch up with the recordings. Just go to the National Astronomy Week YouTube. Do check those out. There's been a fantastic lineup of presenters. Also, if you've got any feedback, go to our website, astronomyweek.org, leave us a message. You can even upload your own drawings. Have you got any images that you've been taking from your own telescopes? Go to the website, under the Mars, on the Mars in the menu, and you can upload anything you like there. Anyway, just to let you know what's going on tonight. Our topic, really exciting, is humans on Mars. We have 3 awesome speakers lined up, including Lucinda Offer, our fabulous chair of the National Astronomy Week team, who has worked so hard to make sure National Astronomy Week 2020 has been the huge success that it has. Throughout the talks, there'll be plenty of opportunity to ask those burning questions you've always wanted answered. So click on the Q&A and get typing. So without further ado, I'd like to introduce our first speaker, Lucinda Offer. Lucinda is the Education and Outreach Officer of the Royal Astronomical Society and the Executive Director of the Mars Society, a former NASA associate who has conducted Mars analog research with 5 expeditions around the world as a part of the NASA Spaceward Bound team researching tardigrades of the Mojave, which I'm very jealous of, 3.5 billion year old stromatolites in the Pilbara, Australia, geothermal vents in Rotorua, New Zealand, and Mars and Titan analogues in the United Arab Emirates. As part of the Mars Desert Research Station, Crew 97, she performed as a NASA teleroboticist, deploying and testing a NASA Google Mars Society rover for scouting future Mars geologic science, field science, extravehicular activities under simulation. Oh, this bit's a little bit easier. Lucinda is currently the chair of National Astronomy Week. Take it away, Lucinda.
Oh my goodness. Thank you so much, Sandra. You know, I never really read everyone's total introduction, but I do appreciate you did that. I'm going to start today with a bit of a video, maybe a shameless plug for the Mars Society from this fantastic video. So here you go, a little bit of entertainment.
Sometime in the next few decades, humans will leave this planet to live in another world.
That means that some people in our life can be the first Martians. How about that?
We're finding out a lot about how to explore Mars in our station. Over 1,000 people from over 40 countries have actually participated in one crew or another.
It's the grandest adventure I could possibly imagine. That is, for me, the most important reason why we should pursue the establishment of life on Mars.
If we go to Mars in our time, 200 years from now, there'll be new branches of human civilization on Mars.
Okay, well, thank you so much for, let me make sure that that ends. If I lose that video, it will start playing in the background. So hopefully I will find it. There we go. Okay. And my camera on. Hello. Hi, I'm Lucinda Offer, Executive Director of the Mars Society. And I just want to thank you so much for allowing me to speak this evening about humans to Mars. I know it's been a very popular question that we've had over the 9 days of National Astronomy Week. So I am very fortunate to be able to speak with you about it tonight. And this is a bit of a nod to one of the speakers that we had. Who will make humans on Mars happen? Well, it's going to be people just like you. So think about that. What can you do to contribute towards a future on Mars or in space, or to continue humanity's existence in the universe? And these were just ordinary people. Back in 1978, they were students at a university, maybe some of like you are currently now, if you're watching from uni, or just ordinary people who decided there needs to be more done about humans to Mars. So they started this conference called the Mars Papers back in the late 70s. And every 3 years they'd have a conference. And one of those conferences, Dr. Zubrin attended. So we have Dr. Penny Boston, who was a student, Dr. Carol Stoker, who I worked with at NASA Ames, and Dr. Chris McKay on the bottom right, who's my former NASA supervisor. And then Dr. Robert Zubrin here is in the middle with this really great sailor's cap on, is the president of the Mars Society, who I currently have the pleasure and honor to work with. And he was inspired by these to actually become an engineer. He was a science teacher at the time, and he became an engineer. So it was late in his career. So it's never too late to get involved. He became an aeronautical engineer, went to working for Martin Marietta, and basically wrote a brand new plan to send humans to Mars that was cheaper, faster, and better than the current one that came out by NASA. And that got published in 1990. And that was all just snowballed from students at a university starting to have conferences and just have discussions and research humans to Mars. And that was the birth of the Mars Society as well. So here's the book that Dr. Robert Zubrin wrote in 1996. So it's now the 25th anniversary come February 2021. And I also want to let you know that if you want to learn more about the history of those university students who started the Mars Society from their university, it's called the Mars Underground. They were actually termed the Mars Underground, who are now planetary scientists at NASA, and that I've had the privilege of working with. And I even went on expedition, I think Sandra mentioned, looking at 3.5 billion stromatolites in the Pilbara of Australia with Dr. Carol Stoker and Dr. Chris McKay, who had never been on an expedition together before. So it was an absolute incredible honor. So I want to talk to you about Mars Direct. So this is basically the mission that Dr. Zubrin created, going from science teacher to aeronautical engineer to an engineer at Martin Marietta at the time. He created Mars Direct, which was very simple. Every 2 years, we sent something to Mars. The first one was just an uncrewed lander that would then bring a little bit of hydrogen with it, and using a process called Saboteur process, would make fuel, oxygen, and water, and just do that on the surface, waiting for a crew 2 year later to come. So you see year 3, there's a piloted, which means crewed people going to Mars, and also a second habitat. So there's some redundancy there, which is really great, because you want to make sure that there's already something there waiting for you. And that happened in year 1 for the humans to use for fuel, water, and oxygen. And that would happen every 2 years. But well, NASA actually adapted this call to Mars Semi-Direct. It's a NASA concept bridge. And they added more launches, basically, and also more redundancies. So they sent the habitats, they sent Mars ascent vehicles, and they sent an Earth return vehicle and an orbiter around Mars. So all these fantastic kind of plan B, plan C's into Dr. Zubrin's Mars Direct plan, to make sure that if anything went wrong, there was something else that could help humans get back to Mars. Sorry about that, I didn't mean to go forward. Let me go back to that, there we go. So that was also year 1, year 3, year 5. And before you know it, by year 5, we would have a settlement of humans on Mars. And if anything went wrong, they would have an orbiter or a lander. And also the difference was that because it's NASA, they always want to bring someone back. So they also built in that there would be an ascent vehicle to bring humans back to Earth. So it would never be a one-way trip. It would always be humans to Mars and humans could come back to Earth. And now I can't go forward. There we go. So in 1998, based on Mars Direct, Dr. Zubrin, when we started the Mars Society, and it was really basically, it snowballed from his Mars Direct plan and his publishing of the Case for Mars book. We held a conference, and the people at that conference said, we need to organize. And they started chapters all over the United States first. So it became at the banquet, everyone got into different round tables amongst their states. And that's how the first Mars Society started in 1998. And then from there, they used Dr. Zubrin's plans to build our first habitat. And it landed in the high Arctic on Devon Island, called Flashline Mars Arctic Research Station. And it was built by those gentlemen there that are pictured in front of the HAB. And it didn't land very well, actually. Some of the parts were, it was dropped by a helicopter, and some of the parts were damaged, but they built it anyway. And then the Mars Desert Research Station, we have one in Utah called MDRS. This is a really early picture, and you see it says the Musk Foundation there. So he was also an early supporter of the work that we were doing, which was basically Mars analog research. So here's the interior of the HAB. They're both built the same specs. The top floor is the one on the left, where you see privacy rooms for a crew of 6, a kitchen and a sink, a dining table, and what you don't see on the bottom are computer workstations down here. This is the ground floor, and you have 2 airlocks. You have an EVA, which is where all the simulation suits and helmets and recharging capabilities are in an EVA prep room. Here was where the analog astronauts would suit up. We had a science and lab space here initially, but that actually has now been moved on as we've expanded. And again, redundancy here, a second airlock, and then a shower, and this is a toilet. So just as any humans would need, everything that they would need for the comforts of home, like a shower. So the Mars Society has been conducting Mars analog research since 1998. And I thought I'd just share with you very quickly some eye candy, beautiful images of our simulation analog astronauts conducting field science. So that's primarily what we do. But we also, we have geologists, we have physicists, astronomers, we have biologists, etc., all different types of backgrounds in engineering and science. But we also have teachers, we have journalists. So all walks of life want to become a part of a crew and simulate living and working in a team, really, because there's a lot of group dynamics that you learn about once you're living in a very small 8-meter diameter tin can, basically. So this is a picture in the top left-hand corner of what our current facility looks like. You see a diesel generator, we have a solar array, and that dome there is our science dome. And we do astronomy as well, so you see an observatory there. And in our science dome, it's fully kitted out to conduct all different types of science research. And you see a fume hood. In the upper right, one of the observatories that was originally donated to us by Elon Musk is now a solar observatory. And we have a green HAB. And we do have lots of TV crews that come out to the Mars Desert Research Station from all over the world. So if you become a crew member, which you can volunteer, right now we're under COVID lockdown, but we will start up again soon. And then you can volunteer to become a crew member at the Mars Desert Research Station. Here's a picture from 2019. So again, you see 2 observatories out there. I believe this is the brand new one. Here's our solar array. Here's the old observatory donated by Elon Musk. We have a tunnel that leads to our science dome. And then we have a green HAB. Here's the Mars Desert Research Station. Over here is an engineering module where they do repairs and things like that. In the United Kingdom and in Europe, you may be familiar with someone called Mars One, an organization that no longer exists, and their concept design was based on Mars Direct. They unfortunately were looking at a one-way trip. I know it was very, very popular here in the UK, but that would be something that NASA wouldn't get behind. And then, of course, I'm sure you're familiar with SpaceX. And compared to Mars One's very stiff and rigid astronaut suit, these people look very, very comfortable on the surface of Mars. And I'm thinking that is really what SpaceX are looking forward to creating for humanity. But of course, it hasn't been easy getting there. It's a very political thing to spend a lot of money and to get behind. Obviously, the Apollo moon missions, JFK, who said, you know, we were going to send men to the moon, humans to the moon in 8 years. And how did that happen? Well, honestly, he unfortunately lost his life during his 2 terms as president. And it was really Lyndon B. Johnson who, to honor JFK's legacy, said, I am going to fulfill his promise to America to send men to the moon, and continued that space program. Since then, however, it has been every new president that we have in the United States puts their own stamp on the space program, and it changes every 8 years or 4 years if they don't get reelected. So the Mars Society has always advocated for humans to Mars in a decade, and that is mostly why. Because we went to the moon in 8, we know it's likely not going to happen if it's not within a presidential term. And it seems like a really quick turnaround time to get humans to Mars. But we did it to the moon, and we had never been there before. We had actually less information and research on humans in space then than we do now. The IMBP, which is in Russia, that did biomedical problems, has been doing research for a lot longer. So we have really a lot more information than we did when we went to the moon. And then, of course, Blue Origin with humans in perhaps adventures in lower Earth orbit. And then we have, obviously, Elon Musk, who, again, also adapting Mars Direct, a huge supporter of the Mars Society, is advocating for humans to Mars. And this was interesting. We just had our Mars Society conference just a week before National Astronomy Week. And we had Elon Musk join us for about an hour, very generous of his time with us. And they both said together, where there is a will, there is a way. And Dr. Zubrin, the president, said the Mars Society will provide the will, and Elon Musk said, well, SpaceX will provide the way. And so that is what the future we're looking forward to and working towards. So this is a common question we get: who will get us to Mars? Well, you will. You're going to continue to carry the torch. Of course, we would like it to happen sooner than later, but there's so many other factors that make this happen. And really, if you decide or choose that this is what you want humanity to do, then you need to be very vocal about it and take action. The Mars Society is not a society or organization that talks about going to Mars. As you saw in those images, we take action and we do it. We're starting to simulate, which is very similar to what the lunar astronauts did before they went to Mars. Went to the moon. So, right, none of them were geologists. They were flight pilots, right? They were pilots. And so they had to be taught geology, and then they had to go out and simulate doing geology using the tools that were created for them to pick up the very precious cargo they had to bring back from the moon, which were rocks that we study to this day to learn more about the solar system. But who will be those first Martians? Well, to lay a really good foundation, engineers and scientists. And I just realized I'm going over time, so I'm going to quickly hurry up. And teamwork is going to be really important. And then the Spirit and Opportunity, the PI, Stephen Squires, who sent those rovers, said that humans should follow the rovers. And it creates technology. So AI Space Factory, here we have Marcia building 3D homes and habitats using in situ resource utilization, basically living off the land, the resources that are available to us on Mars, and building a home from that using robotics. And even the Design Museum in London last year had this fantastic exhibit on a future on Mars and what that might look like. And you could experience it at their exhibit. So a couple of my really favorite quotes, Dr. Robert Zubrin, the president: if we can, we should not just bring life to Mars, but bring Mars to life, and he thinks we will. And then my former supervisor at NASA, who thinks when he looks out at the universe, the most beautiful thing he sees is life. So he says, go forth and spread life, because Earth's gift to the universe, he thinks, is the gift of life. And I absolutely agree with him. And you could see that wonderful quote when he says it in the Mars Underground movie, which is free to watch on YouTube, by the way. And then I wanted to leave you with one of my favorite images from Flammarion, who was suggesting here that humanity reach beyond the sky And then a brand new 21st century image by Marco Melgrati, who's also saying that, but evolving humanity from our beginning to beyond. And I absolutely love that piece. Thank you so much. Again, I'm Lucinda Offer from the Mars Society, and I want to let you also know that there is a Mars Society in the United Kingdom, and I'm the vice president of that organization, and we would love you to join us. Thank you.
Well, thank you, Lucinda. That is giving us a lot of food for thought on that one. And I'm going to introduce our next speaker, Mike Curtis-Rouse, who is head of manufacturing for space at the Satellite Applications Catapult based in Harwell. With a background in advanced manufacturing, metallurgy and robotics, he's an expert and thought leader on disruptive technologies across multiple sectors. So here's Mike to give us our next talk.
Great, thank you very much, Sandra, and I will just share screens. So hopefully, Sandra, can you just confirm that that's up and everyone can see that?
Yeah, that's good.
Brilliant. Well, thank you very much for the opportunity to speak this evening. It's fantastic to be able to follow such an apt and timely presentation that Lucinda has just given. As Sandra says, I'm Mike Curtis-Rouse. I work at the Satellite Applications Catapult in Harwell. And I'm just going to talk to you about something we call Murphy. And Murphy was the Mars-Utah rover field trial investigation, which was a UK Space Agency funded field analog trial in the Utah desert in 2016. And I'm just going to talk you through a little bit about what we did there, why we did it, and actually how that relates to our journey to Mars and potentially beyond. So why were we doing this? Well, fundamentally, we do field trials for reasons to validate robots and systems and spacesuits and a whole variety of different technologies before we physically go somewhere. There's no point going somewhere a long way away, be it Mars, or actually potentially be it close to home, be it the deserts, be it the seas, be it the mountains, without ensuring that the kit that you have actually works. Because if you don't have that kit working and you get there, then actually it's very difficult to know that it's going to work. And if it's going to work, you really want to know that it works well and does what you want it to do. So we were doing this to prove out tech capability for the UK. We were doing this to develop experience for UK researchers for future missions. And we were using this to basically also test out a robot platform, which is very similar to the ExoMars robot, which is due to go to Mars in 2022. And we were doing this with a variety of partners. You can see the logos on the right-hand side, the UK Space Agency, the Canadian Space Agency, DLR, who are the German Space Agency, and of course, the US Space Agency, NASA. We were also doing this with a variety of partners in the UK. So this was very much a UK-centric mission. We split it into 4 quite distinct areas: mission operations, platform operations, the platform being the robot, science operations, and logistics and support. And you can see some of the universities here. And we had a wide range of researchers, over 75 involved in total, coming from a myriad of different organizations, most of them in the UK, but a couple in Belgium, like Jonam Research Digital, and some other groups around the world who were supporting us. So it was a UK operation, but at the same time, we had some international support. And we eventually had some engagement with the Mars Society as well, which I'll get to later. So why are we doing field trials? Well, we're looking for future missions like ExoMars 2022 landing sites, and the Aram Dorsum, and you can see this image in the background, is one of the 4 candidate landing sites. Back in 2016, the landing sites hadn't been decided. Now there's a much greater certainty exactly where ExoMars is going to land. But at the time, we were looking to gain experience of potential landing sites, and landing sites were on Earth, which we could use as equivalent experiences. Now, as I said before, we clearly can't go to Mars first to test out equipment. We need to validate that closer to home, and in this case, on Earth. But the question is where do you go? Well, there are many places in the world which have similar sites, similar landscapes, similar geology to Mars. Some, for example, in Iceland, others are in Spain, and in this case, the ones we were looking at were in Utah. Now, you can see probably a degree of similarity between the two images I've just shown, the previous one of Aaron Dawson and this one, which is basically the Utah desert. And this is a Utah desert in the same location that the Mars Society have one of their desert research facilities. So just to ensure that everyone knows where I'm talking about Utah, Utah is in the continental United States, towards the west, in the proximity of effectively New Mexico, Arizona, and California, surrounded by Nevada, Colorado, Wyoming, and Arizona to the south. We were basically going to a small spot near the town nearby was called Hanksville, and it's a very small, very typical American frontier town. In many respects, it took longer to get to the actual site in question once we arrived in Utah than it did getting from the UK to Utah in the first place. So, as I said, practice makes perfect. We went there to practice technologies. We went there to demonstrate capabilities that the ExoMars rover will do in 2022 and beyond. But we also went there to test out some concepts that the Canadian Space Agency, NASA, the UK Space Agency, ESA, and many other agencies are looking at, which is what we call sample fetch. And this is about having two robots working in unison together. One robot which goes out and effectively collects samples, and another robot at a later date which recovers those samples and returns them to a Mars ascent vehicle and brings those back to Earth for inspection, interrogation, so we can gain and glean a greater understanding in terms of what makes up Mars and potentially looking for those key biomarkers. A biomarker in conventional terms is an indication of life. So we didn't have the ability to take an ExoMars-like platform, as shown on the left-hand side. We just simply didn't have the budget to deploy something this large or this complex. But instead, what we basically took was something very similar. We basically built an analog of the robot. So this is effectively the ExoMars rover. We built something slightly different. So we built a robot using a platform supplied by the University of Oxford with a variety of instruments on it, which were very similar to the ExoMars platform. This is Q14. Q14 is a relatively small, low-cost robot. And when I say low cost, we're talking in the hundreds of thousands, not the hundreds of millions. So a very significant difference. And one of the key aspects as well is we had to be able to get Q14 from the UK to Utah relatively quickly. The whole field trial was put together in a relatively short duration. From the start to the end, it was just under a year. And from a space perspective, even from a field trial perspective, that's incredibly fast. So you can see there's a variety of instruments on here. I'll talk to detail in a few minutes about some of the systems on here. But for the most part, we were looking at using imaging systems and a little bit of drilling, etc., to evaluate associate technologies. So controlling the robot wasn't just about having the robot out there. We also had to control it. So we had an established base in Utah, while we also had a base in the UK. But what you had to do, and you can see this basically on the left-hand side of the screen. Some of you will be familiar with this. This is basically a wireless router, very similar to those you have at home or in workplaces or in cafes, etc. And in the distance in that basic red blob, you can see Q14. And if those of you with keener eyesight will be able to pick out effectively some ramps, which is effectively our simulated version of the landing vehicle, which would have delivered Q14 or ExoMars, depending on your perspective, to that specific site. This link in the foreground is basically how we're controlling the rover. And then that link then linked back to our actual base of operations. And this is the UK base of operations. That big tent-like structure was everything for us. So in the same way the Mars Society have a desert research station, that was the UK's equivalent of a desert research station. So that orange dome provided everything from our mission operations center to our kitchen, to our store, to in the event of a really serious storm, which we fortunately didn't happen during the time we were there, our emergency refuge at the same time. In the background, you can see the various tents for the people who were out there operating the rover, ensuring the rover was effectively protected from the environment, and the environment includes everything from curious people to potentially interested wildlife. So quite a breadth of activities. And of course, there are a few vehicles there, so we can basically get around, because we're really in the middle of nowhere. And even the nearest town, Hanksville, is still a good 30-minute drive to the main road. So we have to have vehicles there to get around, but more importantly, if we have a problem, we have an emergency, be it with the actual robot or be it an injury with one of the personnel, we have to be able to get back to Hanksville. However, back in the UK, and this is the Mission Operations Centre at the Satellite Applications Catapult in Harwell, this is where the control of the rover was going on. You can see on the screens in the background, there's an image of Q14's head. If you consider effectively the upper mast of the robot, the head. And in the foreground, you have a whole series of mission operators, the mission command team, the scientists, etc., all who are basically performing the same roles that the scientists and the engineers and the technologists will do when ExoMars eventually gets to Mars. And this is broadly the same as any mission control facility. It doesn't matter whether you're doing a lunar mission, a Martian mission, a mission to Venus, or somewhere potentially else. We still need mission control-like capability. And the sort of things we're doing, these are effectively the planning tasks. So we were rehearsing and practicing effectively an 8-day mission, effectively each day being what we're terming it as a one Sol. So these are the plans being shown for Sol 7. So in the top left, you've got the target overview. What are we aspiring to do? Where is the robot in relation to everything else? On the top right, we've got the plan. What is the rover going to be doing today? Well, the top line there is basically characterize the near rover area with red, green, blue stereo panorama and with targeted cameras and inspection capabilities. You can see in the lower left, effectively where the robot's been and where it's going. And you can see some of the various artifacts we've named. For example, Monday Rock, Saturday Rock. You can see we had a pretty good imagination in terms of what we were calling things. And then finally, where are we in terms of the 8-day mission? And that's in the bottom right-hand screen. So we're practicing these tasks and ensuring that UK researchers, engineers, technologists, scientists, etc., can actually do this in practice before they potentially do it in anger. So this is a typical image from some of the cameras on the rover. So PanCam is a panoramic camera, and ExoMars has a PanCam instrument built in the UK, designed to go on the ExoMars instrument rover. And you can see this is the typical image. And if I took away the other pictorial information there and told you that this wasn't Utah, and you ignore those clouds in the sky, it would actually be relatively hard to say this isn't Mars. It looks like Mars, it feels like Mars, and that's why we're there. And that's why Mars Society are also there, because if it feels like it and it looks like it, that's the best way to validate something which you haven't practiced before. As I said, the team was big. So we had close to 75 people involved, mission scientists, engineers, support staff from pretty much every discipline. And this isn't just science and engineering. We had people involved who had backgrounds in the arts, in the humanities, everything from effectively feeding people to ensuring that we were not damaging the local wildlife, to ensuring that we had logistics in place to get things to the right places. All of those were as important of being able to run the robot, being able to run the mission control facilities, and be in the position to do the science that we were there to study and practice. So the team really represented pretty much the background of the UK. Multiple nationalities. We broadly had an equal mix of gender. We had different experiences and different ages. And that's one of the key things about space. Anybody can do it. You don't necessarily need to be an engineer or a scientist to get involved. One of the really interesting things we were doing, and it was literally by sheer happenstance, was by the proximity of Mars Society being in the local vicinity. Now, other agencies like the Canadian Space Agency and NASA are much more cognizant of Mars Society's existence than perhaps the UK Space Agency. One of the instruments we took out with us is being held by this analog astronaut from the Mars Society in his left hand. And this is basically a drill developed by the University of Leicester designed to split open rock in a really clean way for future astronauts to use. Now, we took this out with the expectation of we might be able to, if we had some free time in the field trial, we might be able to find some rocks and investigate. We realized when Mars Society were there and they very kindly offered to try and use that piece of capability actually in anger. So we've realistically there got Jonathan basically using this rock slicing tool in an analog situation in a way that really proves out the technology. So you can see that the rock, basically, the drill is basically, it's a percussive-based drill. It's placed on the top of the rock surface, and it basically is like a kind of a reciprocating hammer. It hammers away at the surface, retracts, and then hits it really hard, and eventually you can split the rock, and you can then split the rock to inspect to see what's inside. So you can see here in this close-up that the drill is being pushed up against a rock, but Jonathan's wearing gloves. And if you look in the previous image, for example, he's wearing effectively a synthetic spacesuit. So this is a really good way of evaluating a tool in a very equivalent analog experience, and a tool in the way that will allow us to understand how to build tools and how to build experiments and how to build instruments, which will help humans when we go to Mars. And I emphasize, it's a question of when. It's never going to be a question of if. Earth is an interesting place to be, but there is so much more out there to explore. This is my final slide, and I just want to say again, space isn't limited by who you are. It's only limited by our imaginations. Thank you very much for listening. Thank you to Lucinda and Sandra for the invitation to participate tonight. And I'll hand back to Sandra now. Thank you.
Thanks very much, Mike. That's brilliant. I'm going to go straight on to our final speaker so that we can take some questions at the end. Keep on bringing your questions in. Keep on typing those questions. I'm sure you've got lots of burning questions to ask. Anyway, to our last speaker is Professor Sarah Batu, is the director of the radiobiology unit at the Belgian Nuclear Research Centre. She's also guest professor at the Ghent University and the Catholic University of Leuven, teaching and directing research in the field of radiation biology, radiation protection, space biology and medicine, which sounds absolutely fascinating. Over to you, Sarah.
Thank you very much. Thank you. It's really an honor to be part of this final evening of your National Week in astronomy. It's really a pleasure. I'm very happy about that. And thank you very much for this beautiful introduction. I'm going to speak now about another aspect that we need to cover and to speak about is the human part, and how do we prepare astronauts to really be able to encounter and to deal with these missions to Mars. So my talk will be about how to protect astronauts, and I will go to more specific aspects, which is the space radiation aspects. We have quite a lot of know-how and knowledge and expertise about the impact of space missions on human health since the first orbit in 1961 by Yuri Gagarin, that lasts for about 1 hour and 40 minutes, up to now. In the ISS, in the International Space Station, where astronauts are usually spending between 6 months and 1 year of mission. So we know what are the impact of space conditions on their health. And so we can already kind of extrapolate a little bit what can happen, what could happen for longer mission to the moon or to Mars that would last for months to years, of course. And this is a huge program, a very important program, which is a kind of a universal program, the Deep Space Gateway, to really bring humans, to bring the crew inside the spaceship to explore the solar system. And one of the first steps will be the moon, and thereafter to go to Mars. And this Space Gateway is the most distant human space missions ever attempted, and is really the testing ground for even bigger challenges of long duration human missions in deep space. And one of the main showstopper is ionizing radiation, space radiation. On Earth, we are really well cocooned, we are well protected with our magnetosphere. 99.9% of the radiation, space radiations are stopped, are blocked. And we also have an atmosphere that also stopped a lot of the radiation coming from the cosmos or coming from the sun, for example. But if you look here, the risks increase much more going to deep space. And if you look here at the level of the Earth, on Earth, we have about 1 millisievert of annual dose that the population receives. And if we go to the ISS, we have a dose which is about 150 to 200 times higher than on Earth, which is already not neglectable. But going further to the moon or to Mars, we see that even going to Mars, we have an annual dose which is about 1,000 times than what we encounter on Earth. So what can we do about that, and how can we protect ourselves? First, we need to better know what these space radiations are. And just as a kind of a definition for you, I would like to give you an idea of our enemies, in a way, how to define them, to characterize them in order to be able to mitigate them. So space radiation beyond a low Earth orbit are mainly composed of three components. The solar wind, which is a flux of low energy electrons, protons and alpha particles, which is a continuous flux, and which presents a very low level of risk. So we are not so bothered at the level of radiobiology, so the impact of radiation on human health. However, solar particle events, which are high energy protons, intermittent, like coming from a solar flares, staying for a day or two, they are very hazardous, and for that we have specific protection that are used on board of the ISS, on the International Space Station. Then another matter which is very much concern for us are the galactic cosmic rays, which are high energy protons and alpha particles, and also heavy ions. This is a continuous flux of radiation and very hazardous, for which we absolutely need to find even more mitigation ways, so countermeasures, in order to counteract the impact of this galactic cosmic radiation. So let's see now on the ISS, on the International Space Station, which is really a critical platform to understand, to develop a different mitigation way, and for example, shielding towards radiation or different types of radiation protectants for future Mars mission. The ISS is a very good platform where we can, and where we are studying characteristics of the space radiation, where we are developing different types of shielding, detecting radiation, and very importantly, understanding the impact of radiation on human health, where we, for the moment, follow up astronauts that have spent 6 months to 1 year in space. And this is one of our Belgian astronauts, Frank de Wien, who is placing some of our detectors in order to measure radiation. There are three parts on the International Space Station that are very well protected for radiation, where astronauts can really, in a hurry, if needed, go and hide. And these are represented in the red square. The service module, the water wall, and the lab sleep station are the three main places where astronauts can go in terms of if there is a solar flare coming. And there usually is detected a few minutes before the solar flare is reaching the International Space Station. The next step, as we know, is the moon before we go to Mars, where the level of radiation is 300 to 400 times for the mission above the level on the Earth. But this is a very important step that we are now developing and developing in order to have a first moon village on the moon, in order to test different aspects before going to Mars. One of the aspects that we are currently investigating, which is very important to also develop and study deeply, is the spacesuit, because astronauts will probably and will most probably perform a lot of extravehicular activities. If you compare with the Apollo program, where less than 20 extravehicular activities took place during the entire Apollo program, here on the moon, it's foreseen to have more or less 75 lunar extravehicular activities. So for that, we need a good spacesuit, which would be a second skin, which needs to be resistant to abrasion, to reactive chemical dust, very flexible and very elastic. But to Mars, let's go to Mars, where we know it's a most similar planet to the Earth, and important to understand whether life existed elsewhere, where there is a bit of atmosphere, so where there is some kind of potential habitable environment. What are the main issues and concerns? First, the health risks for the astronauts. We know that higher doses of radiation can induce cancer. They can also induce acute effect on the central nervous system, on the brain, on cognition, on motor function, on the behavior. But also high dose of radiation could induce some cardiovascular diseases, some stroke, but also some cataracts, some lens opacity, or immune dysfunction. We know also the space radiation is very complex and induces also very complex biological damage that are not so well understood up to the day of today. So they are very different, very difficult for the cells to repair. So it takes much longer for a human cell to repair this DNA damage induced by this galactic cosmic radiation. And they seem to have a distinct pattern of DNA damage and repair length. So we need more research in biology using also animal models. We need more human data also, and we don't know if there are, depending on the organs and on the tissue, additive effects if you add microgravity together with space radiation. And also an important issue is that not everyone has got the same radiation sensitivity. So radiation sensitivity varies amongst humans. It varies amongst humans, but it also varies according to the age, with the youngest people being much more radiation sensitive than older people. And also with a difference between females and males. So between female and male astronauts, with female astronauts that would be most probably more sensitive to radiation. So it's important, and there is really a need to develop precision medicine, personalized medicine for astronauts, developing the best biomarkers in order to understand and to monitor precisely and to screen them before going on mission, but also all through the mission in order to develop and give them the proper medicine before the damage is too high. So this is what we are currently doing on astronauts that are on the ISS, monitoring their radiation sensitivity before they go to space and when they come back. We also study the different sensitivity of various tissues. For example, here we study the skin, the way skin reacts towards space radiation and space conditions, but also how the cardiovascular system reacts in these conditions. Important also to understand how the brain will be impaired in the longer the mission, the higher the dose, the longer, the deeper the effect on the brain. So this is also very important to study. And another particular important concern is the microbiome. This is the few hundred grams of bacteria that are populating our gut. And this microbiome seems to be also impaired during long mission in space. So this is very important also to monitor, to screen, and to find countermeasures in order to keep a good microbiome, because that will keep the astronauts healthy. The gut microbiome is considered as our second brain, in fact. Important to understand also how we can improve radiation resistance in astronauts through experiments like this one that is going to fly in 2 weeks' time, again, with the rotifers that are going to give us a part of the response and answer in order to understand how we can prepare astronauts better to become even more radiation resistant. We need also life support to go to Mars, and we need to feed the astronauts. And for that, we need microorganisms, bacteria and plants in order to recycle urine, feces, and to produce food. So that's why this ESA program, the MELISA program on life support is also essential. We are working on that. I was very lucky to go to Antarctica, which is also one of the very good analogs in order to simulate part of the stress induced on the astronauts all through their mission, the stress of isolation, of confinement. You can reproduce that in Antarctica, and that was a very interesting mission in which we studied how the immune system cope with this isolation and confinement situation. So there are different ways to improve radiation resistance in astronauts, enhance shielding, doing a medical selection of the astronauts, developing radiation protectants, studying the biomarkers, decreasing the metabolism and inducing a kind of hibernation, or also developing regenerative technologies, taking on board all kinds of tissues from the astronauts in order to be able to regenerate a tissue that would not work and would not function anymore in space. And let's not forget that all this space research and space radiation research directly benefits to patients because all the research which is performed helps us to kill better cancer cells by developing better radiotherapy treatment and also understanding cardiovascular diseases, brain neurodegenerative diseases, and to better treat these diseases. So if you are interested by this subject, I would like to invite you to listen to the TED conference where you can see the link here on space radiation that I gave a year ago. And I would like to thank quite a lot of people, as you can see here, and thank you for your attention. And if you have any question, I would be very pleased to answer to them. Thank you very much.
Thank you very much, Sarah. That's brilliant. We have got lots of questions coming in. So if you could just stop sharing your, that's brilliant. Thanks. So I've got one because I think it's going to be pleasing to all our panelists. This is from Sophia, who's aged 10. She says, I want to be one of the first people to go to Mars. On the first mission to Mars, how many people will be in the crew? She's pretty excited about this. I don't know who's going to answer that one. Anybody who can answer that one?
Well, I can say that our habitats fit a crew of 6, but that, you know, I guess whichever organization is planning their mission, I think NASA's fitting their capsule for a crew of 4. You know, it is safety in numbers. So there is something between 4 and 6 on a crew.
And on a psychological point of view, 6 people seem to be the best number, also.
Now I'm going to introduce a co-host, Robin Schedule, and who's going to alternate the questions with me. So over to you, Robin.
Hi there. Right. Yes, we've got a nice one here from Charlotte. Hang on, it's come off my screen now. Yeah. If you had to put money on it, when will the first people land on Mars? And it's a very open question.
So the Mars Society advocates for humans to Mars in a decade. You know, we sent humans to the moon in 8 years. And you know, so we think that maybe just a couple more years after that. But honestly, it's for that reason that I mentioned, which is in the United States, you know, term limits for presidents and the change of space programs. That's
within a decade. Now, we were expecting a sample return back in 2000. We were expecting a sample return mission within a decade, and we're still expecting that within a decade. We won't get a sample return until 2031. So do you think that's realistic?
I think if we were determined and said we're going to send humans to a planet, I think that then we would have to be dedicated and committed to seeing that through. So it would be different than doing scientific research where you probably could say, oh no, we couldn't make that. When you're humans involved, you can't do that. So I don't think it's a fair comparison.
And Charlotte's had a follow-up question. Will the first flights have to be a one-way ticket?
I don't think ethically, I don't think you can send people. You need to know the risks and to have found the best way to mitigate the risks, but I don't think it's responsible to send people for, I don't think it's the position of the European Space Agency.
I agree. I think there's an ethical issue with sending humans to, off the Earth and not having a plan to bring them back. And that's exactly why NASA also created Mars Semi-Direct, which was the plan to bring humans back to Earth.
Thank you. I've got one here for Mike. Do you simulate the lower Martian gravity? And if so, how?
It would be intriguing to be able to do so, but no. Simulation of lower gravity than that on Earth anywhere is incredibly difficult to do. You can do it with some very clever balancing of weights and things, but it's not realistically something we can ever do in field trials. And the reality is the gravitational influence on Mars is not significantly dissimilar to that of Earth's, unlike the Moon, for example. So we don't see any significant gain, or at the same time, we don't see any significant disadvantage to Martian-based operations.
We can simulate microgravity in the lab on cells with a device, for example, like the random positioning machine, which places cells, human cells, in floating position continuously. So, like astronauts are floating in space, and that helps you to understand the molecular mechanisms that microgravity triggers inside the cells. So that's really helpful to understand what happens at the level of the cells.
Have experiments like that been done on the International Space Station?
Yes, a lot of cellular experiments are taking place on different types of tissues. For example, on cardiovascular, as I showed, on the skin, on brain cells. It's a bit more difficult for brain cells because they are difficult to cultivate, but on all types of different cells from the body, in order to, because this is really the first questions you have to ask yourself is how each type of cells in the body is going to react, and then that gives you already a very good information, and thereafter you can think about developing tissues and organs and small organs, organoids. This is the next step of complexity, because it's not always easy and possible to understand everything which is taking place inside the human body on the ISS, only partially, but not totally.
Okay, we've got 3 questions here, all to do with radiation, and one is from Peter and Steve Bosley. I assume we also have to have radiation-proof electronics. And then also Pat Tuck asks, what are the safe areas on the ISS lined with for protection? And finally, Steve asked, do the Mars rocks emit radiation as some rocks do on Earth? There you are. That's probably one for you, Sarah.
Yes, so thank you very much for these very interesting questions. So right now, so there is quite a lot of research taking place on developing the best shielding system, so and the best material to shield. The best ones are the ones that are composed of a high proportion of very small atoms, like hydrogen. So the 3 places that are very well protecting on the ISS are the ones that are all containing a lot of water. So water, it's hydrogen and oxygen. So that's really a good protecting way. And the 2 other places are containing quite a thick layer of polyethylene. And polyethylene, it's a long carbon chain with hydrogen on each side. So really a lot of hydrogen. So these 2 other places are very well protecting with polyethylene. So that's one way, but you can also work on boron, with boron, which is a very small atom as well. And I know that NASA is working a lot on boron molecules. And other very small atoms, but indeed these are the best protecting places. And unfortunately, polyethylene is not very very resistant, so you can't really have a space ship with polyethylene outside. You need to have it inside and in a certain thickness. But for example, polyethylene is used in Orion mission for the vest for the astronauts. The vest which has been developed is also a thick layer of polyethylene of a bit more than a centimeter thickness.
I'm going to ask the very first question that was asked. Is there anything on Mars that is related to the Moon?
I think, should I or someone else maybe?
I could comment. I mean, the one thing about Moon and the Mars and Venus, and in fact anything off Earth, is that very fact. It's not on Earth. So if we want to practice operations, everything from eating to washing to cleaning to using the toilet, frankly, those basic operations, doing those somewhere which is closer to the Earth and not as far as Mars, but still on another basically world, or in this case a satellite, is phenomenally valuable. So the biggest similarity, I would say, is the distance. They are far away and you're basically on your own. There are some other synergies in terms of material and geology and things like that, but broadly the geology of the moon and geology of Mars are very different things. But the radiation, I suspect Sarah will probably comment, is also another major factor.
Yeah, indeed. But indeed, all the tests to be performed on the moon, test of the equipment, of the technologies, of any type of the moon would be the first test bed for Mars, I would say. Yes. And in terms of radiation, of course, the mission is longer to go to Mars, and depend on when we leave and at the best moment, and the shortest mission. We are speaking about a few months, and then on the site as a settlement also a few months. So in terms of cumulative dose, if you look at the length, the whole duration of the mission, you will have, of course, a longer and a higher dose of radiation than on the moon.
We've got quite a few questions. I'll try and summarize them about volunteering to go to Mars. And obviously you've sparked a lot of interest, and we've got volunteers. Maybe some of them are aged at the sort of 10 and 15, where you might expect them to be the sort of first people who might be on Mars. Someone says, what's the best career path to go onto Mars? Do you have to be in the military to have the right sort of background to go to Mars? What country is likely to be provide the first Martian? It's a rather open question. That any suggestions there?
I'd say that realistically, first countries there's a good chance it will be the United States, but it could equally be China. There's even the possibility it might be India. And the European Space Agency clearly has a wide representation, including Canada. So it's going to be a tough one to call First Nation. But what I can say is, in terms of background, for now, backgrounds in science, technology, engineering, STEM-based subjects, those are the places you want to stick with. In the future, I think the people in demand on Mars are going to be people with other skills, ranging from plumbers to chefs, to people who can fix your shower, because I can certainly tell you, after a long day on the surface of Mars, if I couldn't get a decent meal in the shower at the end of the day, I'd be pretty angry. So it's in the same way as, if you want an example, look at the operations in the Antarctic bases. So look at what the British Antarctic Survey are doing, for example, and look at the people you've got out there in terms of doing the research, but look at the people you've got out there in terms of making the base work.
I noticed also that Sarah indicated that young people are more susceptible to radiation. Does that mean, in fact, that the first person on Mars might actually be, if not of my age, then someone more mature than the youngsters?
It's a very good point indeed. In terms of radiation sensitivity, it would not be responsible to take very young people. Having said that, we need new staff member, new astronauts for the new missions to the moon, to Mars, and they will be, if I understood well, there will be at the start of next year a new recruiting campaign. So if you are interested in applying, I think it's from 18 years old onwards. Do that and apply and try. It's really certainly a good way. And as mentioned, yeah, the STEMs, scientific, engineering, are for the moment the most important, I would say. But we will need, and yeah, it's not only being an astronaut, it's all the work around the research, the preparation. There are thousands of people that are needed, and all kinds of disciplines are needed for that. The astronaut is one aspect, but there are really thousands of other jobs that are related to space, legal aspects, all kinds of aspects, economical aspects. So different types of backgrounds are needed.
I think, I mean, we're running out of time, but I just going on from that, one question here says, do you think they will send a medical doctor on the first mission to Mars, or any, to keep track of the crew and assist them?
Absolutely. That's part of every crew that we have. We usually have a commander, a second in command. We always have a health and safety officer. So someone who anytime, and this is just a simulation in the Utah desert or in the Arctic, we always have someone with some sort of medical background or training who can assist the crew, and especially in our Arctic hab, because they're more autonomous, it's difficult to get to them in a quick manner, and so we need someone to be part of the crew who can help someone.
Yeah, thanks. And I
Okay.
think, do you think we've run out of time?
I fear we have, because we've got astronomers straining at the leash to show us things in the sky. So at that point, thank you to everybody. And Sandra, would you like to thank your guests as well?
Thank you very much for our panelists. That's been absolutely fascinating, really brilliant. Thank you very much. And there are still questions in the question and answer box. So if you are able to stay on for a little while and type the answers in there, that would be very grateful. Thank you very much. But thank you. Brilliant. And then now I'm going to pass over to Robin, who is an excellent host for the observing session this evening. Thank you very much once again.
Thank you all, and hopefully we will actually see the object of our interest tonight, and that is the planet Mars. I'm going to introduce our observers now. I will share my screen of the locations of them. Here we are. This is where they are. We have got John Dolan over in Ireland. I haven't checked with him whether it's clear yet. We've got David Arditi in just 15 miles to the east of me in London, Ian Sharp down in the south coast, and then we've got Agapios down in Cyprus. So between those, we should get some clear skies. So first of all, I'm going to go over to David Arditi in Edgware in London. And what's the sky like where you are, David?
It is partly clear at the moment. So I will see if I can show you Mars. You may now be able to see it.
Oh, that's brilliant.
This is a live view from a 14-inch telescope located in Edgware in the northwest corner of London. And this is the view from a colour camera, as you can see. And there's also a Barlow lens on the telescope to enlarge the image. Now, hopefully, can you see my mouse as well?
Yes.
Yes, so this is a view of Mars with south at the top, celestial south, vertically up. So this point here, this is the south polar cap of Mars, tiny residual area of ice, which is almost completely melted at this season of the Martian year, mainly carbon dioxide ice, but also some water. And you can also see the southern hemisphere albedo markings. And this marking here is the Solus Lacus, this dark area here. And this area over here is called Argaea. And this yellowish area on the top of the disk, this is dust. This is the dust storm that we've been following for the last week, and it is just rotating into view. Mars is rotating from left to right in this view, and there's probably a finger of the dust coming round here just on the southern side above the Solus Lacus. So I'm judging that from having seen more detailed images of Mars taken from elsewhere recently. You also see a thing that we haven't mentioned, that Mars has a phase. There's the terminator here. This is the line between the light and the dark side, daytime and nighttime side on Mars. So we're not got a completely full Mars because it's past opposition. It's past the point at which it was opposite the sun in the sky as seen from the Earth when it was completely full, which was about a month ago. So it's now past opposition. So we're now seeing about an 80% phase or 90% phase. We're seeing the gibbous phase, so not a complete circle of Mars. So we've been following this dust storm, and we don't know how it can be developed. So that's a point of interest. It's unpredictable. Sometimes dust storms become global, and the whole surface is obscured, as seen from telescopes on the Earth. But sometimes they just fizzle out. I would say it's unlikely that this one would become global from the season of the Martian year, because it's now autumn in the southern hemisphere. So there's the less energy in the atmosphere. But we never know. And this kind of observation is actually useful to the people planning the Mars rovers, because it might be useful for them to know if dust is coming their way. Of course, you get big, you get rapid winds on Mars, despite the low pressure of the atmosphere, only 1% in the atmosphere of the Earth. You get winds, and so dust is deposited on anything that we send to Mars, and in quite thick layers, and can knock things out. So that's what I'm seeing here at the moment. I've also got the moon in the sky, and I've got a separate telescope on that. But I will now pass over to see if we've what the other observers in different parts of the country are seeing at the moment.
Okay, super. That's a really nice image, and I think that Agapios over in Cyprus might have something for us as well. I can see him there. Can we bring him in now, please? Agapios, over to you.
Hello, everybody. Greetings from Cyprus. I'm outside, as you can see. It's another beautifully clear night here, and I have Mars as well. Let me just share my screen right away. I hope you can see it. So I've just rotated my camera to match David's view. Are you seeing that? Is that coming through?
Yep.
Yes.
Okay. So as I said, I rotated my camera to match what David was showing. And I have to say, I think that the dust storm that we've been following is actually becoming much more active. I managed to sharpen a small sequence I just did a while ago, and I can see quite a lot of dust activity all over the planet. It's looking really low contrast, and it really reminds me of what happened on Mars a couple of years ago when we had that global dust storm. We see quite a lot of detail here. We have Valles Marineris in the center. I can pick out some of the Tharsis volcanoes and Olympus over here. And this is the area that we were seeing last time with the dust activity. But all around this area, I can pick out that distinct yellowish image of the dust. I don't know if you would agree.
Indeed, yes. It's
yes, that's very clear, and we've been watching it develop through the pictures that you've taken since the beginning of the week, and it goes to show that this is one of the hazards of being on Mars. If you look at the pictures from the rovers, they often show little mini tornadoes whirling the dust around, little dust devils, but this is something different again. And I remember the story of back in 1971 when the first spacecraft went into orbit around Mars, Mariner 9, and the people running it wondered what was wrong with their camera because they turned it on and couldn't see a thing, and that's because the whole of Mars was completely covered with dust. Fortunately, this is not so bad a dust storm as that, and we can see quite a lot of detail, but it goes to show that Mars is by no means a quiet planet. Yes. David, have you got any comments on?
Yeah, that's
this dust storm. We've been observing it for, well, observers around the world have been observing it for about 2 weeks. It was first spotted on the other side of Mars, where we could see in the UK. It was first spotted by observers in the Far East, and Christopher Goh in particular, who observed from the Philippines, took some very interesting images of it, and it's only just rotated round so that we can see that part of Mars now, because we see almost the same side of Mars every night. If you observe the same time every night, because the rotation period of Mars is 24 hours, 40 minutes, you see almost the same sides, but gradually over a couple of weeks, then you see the rest of it.
That is the same side from a particular place on Earth, but from the opposite side of the Earth, it's rotated in synchronism with where you are, and they see the other side. So amateur astronomers around the world get a full 24-hour coverage of Mars if we unite the observations from all observers. And of course, over a matter of a couple of weeks, the small slippage of that 40 minutes between one day and the next does give you a view of the whole of Mars. So that's it is a great way to monitor Mars. And I have to say that although we have spacecraft in orbit around Mars all the time, the view that we get of the whole of Mars from Earth can actually be of interest to the people controlling the spacecraft, because we do get a complete view of the planet. And it reminds me of the storm that arose on Saturn a few years back, which was first spotted by amateur astronomers, because although there was a spacecraft Cassini in orbit around it at the time, it was on the night side of the planet at that time, and didn't see the dust storm start to evolve. So us amateur astronomers have still got a part to play in monitoring the planet. Well, that's a beautiful view of Mars there, and maybe we can come back to you in a short while. David, have you got any pictures of the moon yet?
Kind of. It's not a very good picture of the moon. I will show it to you. And it's a very overexposed picture of the moon, because this is taken with a telescope and camera not designed for this purpose. But you can actually, it was when the cloud was thicker, the view of the moon was better, because it wasn't so overexposed. Let's see if I can expose it a bit less, but probably not. You can just about see some of the craters there, but it's overexposed. So later I might get the Celestron 14 on the moon, and if it remains clear, I'll get this highly sensitive telescope, maybe on a galaxy or something.
Right, that would be good if we can have a look at some of the craters on the moon, because they are a fantastic sight. And one of the things I want to encourage people to do is to look at the moon. This is a great time to start looking at the moon, because it is at first quarter. You might think that full moon is the time to look, but no, it's right now when all the details on the moon are thrown into sharp relief because of the side illumination from the sun. The sun is shining on the side of it, as it were, and so we get all these shadows from the craters and the mountains, and showing sharp relief, and you can see the undulations in the surface very clearly at this sort of illumination. We've also got John Dolan over in Ireland, and so I'd like to ask him to come in now. John, can you unmute yourself and just put your video on? There we are. How's things there?
There we go. Well, it's the seeing is rather poor, but it varies from time to time. I'll just show you what I have here. There's a black and white camera. Let me see. There we go. Can you see that?
Yep.
That's what's there at the moment. And anyway, so it's rather blurry, you see, as well. So,
well, I know when we do public observing sessions and we show people Mars through the telescope, and they're expecting to see something looking like those sharpened images that we saw, or like the picture of Mars that is on the opening credits at the beginning, which was taken, of course, by spacecraft. And when you looked at a planet, even Mars or Jupiter, through a telescope, the details are rather low contrast, and you can get a good impression there. Imagine seeing that jiggling around through even quite a reasonably large telescope, and you have to use a lot of imagination sometimes to see the details. But the fact is that it used to be said that the eye was much better at finding details on Mars than taking a photograph. And this was back in the last century, when we had to rely on film. And you can imagine giving an exposure of, say, a second, trying to take a photograph of Mars, even through a large telescope, when it's jiggling around like that, and you would just get a mushy blur. But the eye, as you watch that image, you notice that you can occasionally see just a bit more detail, and the eye was always is very good at picking out those sharp details. So people visually observing could actually see more than people could photograph. These days we have the benefit of video cameras, and they started off using the very simple webcams. In fact, it may amuse people to know that the webcam that I use, the sticky that's on my computer at the moment is actually the sort of webcam that was used for the very first pictures of astronomical photographs. I didn't, having got that one, I didn't never bother to get another one. It seemed to do the job perfectly well. It's a bit limited in resolution these days, but it does the job. And just as soon as webcams came on the market, people realized that they could stick them on a telescope and actually get quite a good view of the planets and the moon, and indeed the sun and other planets. So that is what's transformed our view of the planets. Okay, John, thanks very much. Tell me what other things you have been observing in the last week or so.
Well, in the last week, of course, things were very bad. We were clouded out. Now, so it wasn't good. But normally I do deep sky objects, And,
meaning what? Explain what deep sky means.
So deep sky, anything outside the solar system, so stars, nebula, and galaxies, So I would have a collection of those on my website, but they're fairly standard. So anyway, that's what I do normally.
Yeah. So okay, well, I know you get some very good skies in Ireland, particularly if you go away from the cities. And I remember seeing some brilliant pictures. Well, I've been to the Burren Star Party about 10 years ago, and some of the darkest skies I've ever seen were in the Burren, and absolutely fantastic views of the sky. So that is the place to go if you can get a good, clear sky, which of course is not guaranteed. Well, it's not guaranteed anywhere in the British Isles, is it? Nor is it down in Selsey in Sussex, where I'm afraid we've Ian Sharp is apparently totally clouded up. Ian, we'll come to you next, and you can maybe show us one or two things you've been looking at in the last week.
Yes, Robin, can you hear me okay?
Yep.
Okay, well, I'm afraid, like John, I have just been clouded out. I've not known, a spell as bad as this. In Selsey, we're quite famous for getting clear sky in the UK, where when a lot of the country is clouded out. And one of the reasons why Patrick used to love living here, Sir Patrick Moore, because of the reputation of Selsey. But it has been appalling, and I haven't got any new observations to show you. But may I reiterate some of the sharpening type stuff, principles of planetary? I've got some very good videos of Jupiter and Saturn to show you.
That would be great if you can show us Saturn, because although Saturn is in the sky at the moment, we've seen very few pictures of it. So give us just 2 or 3 minutes or 3 minutes on sharpening up an image.
Okay. Well, I'll show you this. This is I've got a Jupiter image here open, and I'm going through I'm just scanning through the frames here just by dragging this, because you can see that the seeing conditions vary, very, very much. And I just wanted to show you this quickly was when the reason why we like planets to be at a high altitude is because we want to look through as little atmosphere as possible. And this little diagram here, if you're looking straight up, if you're standing on the red planet there, and that's the atmosphere in blue, if you look straight up, you're looking through 1 atmosphere thick. But as the object you're looking at goes further and further down towards the horizon, you can see that you're looking through more and more atmosphere. And at the moment, Jupiter and Saturn are so low in the UK that you'd have to be looking right through, in actual fact, about 4 times the amount of air you would be looking through to at the moment in the UK. But if you mentioned Saturn, let me open up a video of Saturn that I took I think 2000 and when was this? 2011. Okay, so it's a little while ago. The rings are now wider open than this. And again, here's a video. And what I'm going to do is I'm going to get this software here to, this is a video with, let's see how many frames. There's 3,500 frames, and you can see they vary in sharpness. It's actually in very good seeing conditions where,
if you look at the Mars that John just showed in poor seeing, it's very, very, very blurry. Obviously, this is very good seeing conditions, but there are still some sharper frames than other. And what I'm going to do is I'm going to get this software to scan all of these frames. Those of you who have been watching these shows over the last week will have seen this before, but I don't think you've seen Saturn. And now, if you look, can you see this graph on the left? This is showing that it's sorted through all the frames, and these are the quality, the best quality are on the left, and you can see it's classified the frames into the poorest ones on the right. And so what I'm going to do is I'm going to tell the computer to select the top 75%. I'm going to throw away that last 25% of not quite so sharp frames. And I'm going to tell the computer to, hang on, so let me just do that again. I'm going to tell the computer to stack those together. Okay. And for some reason, it's not letting me do that. Never mind. I've previously done it, and what I'm going to do now is I'm going to open up the result of averaging all of those sharp frames together. So I'm just going to select this is what I was trying to produce. I'm not quite sure why I couldn't press the button there. Now what I've now got is the stacked result of all of those frames together, averaged together. Now it still looks a bit blurry, and what I'm going to do now is I'm going to adjust the sharpness of various levels of detail. So now I'm adjusting fine detail, and as you can see, it's getting sharper. I hope you can see this clearly, by the way. And I'm just adjusting this slider, which is slightly larger detail, and I think you can now see Saturn quite crisply here. Is that
that's coming over
clearly?
fine, yeah.
Okay, and I mean here you can see on this particular night, you can see the sun was shining from right to left, because you can see the shadow of Saturn's disk on the rings. And here we can see all the different rings. I'm going to sharpen it just a bit more, just to probably a little bit too much, but you can see now the various the dusky rings in the middle, and this very dark ring is actually a gap. It's Cassini's division, which is the very easy to see on a reasonable night through even a modest telescope. And I think you can even actually see, if you look very carefully, you can even see the planet just through the gap of Cassini's division. Now at the moment, as I say, Jupiter and Saturn are so low in the sky that you just can't see it as clear as this, but this was taken under good conditions. If I sharpen it, over sharpen it even more, you can actually see some little tiny storms on Saturn's belts here, and you can see the various belts on the gaseous planet surface. Well, not the surface, but the gas giant that Saturn is. You can see the various belts, a bit like you can see on Jupiter, but Saturn exhibits less storms than Jupiter. So basically, that's how astronomers, we take videos, we throw away the blurry frames, we average together the sharp frames, and that causes the signal to come out of the noise, and then we sharpen the result. So
that's great. Could you explain? Probably people won't know what the rings are made of. Perhaps you can mention that.
Well, they are individual. They are trillions. I think I'm right in saying. I'm not an expert, but basically. From icy and rocky particles that and objects that can be as big as a car and as small as a football, and I mean I guess, Robin, you might know more. I mean, some of them are a lot bigger than that as well, but trillions of them that together shine, reflect light, and they actually look like a solid thing. But if you were to go up very close, and it is possible to fly spacecraft through the rings and through Cassini's division, etc. So that's icy rocky matter
Yes, I was looking forward to a really close-up picture of the rings from the Cassini spacecraft, which I mentioned, which has now been plunged into the globe of Saturn.
Yes.
Saturn is a gaseous planet, and it didn't hit. It just sort of got more and more under pressure as it descended through the cloud belts of Saturn. But even the closest pictures of the rings didn't show anything other than a slight sort of graininess to the rings. The actual particles, I believe, are really quite small.
Quite small, yes, indeed. I should mention, by the way, that this is a black and white image. It was taken with a single filter, not like the color camera that David and Agapios have been showing you. I would combine this with a green and a blue to produce a color image eventually. So.
And so we've been asked why Jupiter and Saturn are so low in the sky at the moment. And I think one of the points is that all the planets go round in a certain time of a certain period. Jupiter takes 12 years to go round the Sun. We, of course, take 1 year. So every year when we've gone round the Sun, Jupiter has moved a 12th of the way through the sky extra. And so we see it in a slightly different constellation each year. Saturn, however, takes 29.5 years to go around the Sun. So each year we see it in more or less the same place, but just a little bit further along. Yes. So at the moment, Jupiter and Saturn are very close in the sky together, and they are visible down quite low down in the western sky. It's well worth having a look. I'm sure you will have noticed them during the summer months, but they will be almost in line on the 21st of December.
Yes.
They were very close together indeed.
Indeed. And while you were talking, I just sharpened up a similar stack of images of Jupiter, again taken a few years ago, 2011. I'm showing these because they're very good seeing conditions. And there's the great red spot with all of the incredible turbulence that it leaves in its wake.
That's the large circular blob towards the upper left there. Yeah.
Again, this is a mono image. That's an orangey pink reddish storm that's been seen by amateurs for more than 200 years. It's been visible. I'm not a great, I don't know exactly the date it was discovered, but it's been there for a couple of hundred years at least, and it changes slightly, but and there is some fear that it's getting a bit smaller. But it's a beautiful thing, and you can see it very clearly with a good telescope, with an eyepiece.
So the good news is that Jupiter is at its lowest around the sky at the moment, and Saturn, and over the next few years they will be becoming higher and higher in the sky. And as I say, Jupiter takes 12 years, so in another 6 years it will be much higher in the sky. And who knows, we might have another National Astronomy Week when Jupiter and Saturn are higher in the sky. That would be fun, wouldn't it?
Or you can travel like I did here to get it higher.
Yes, that's true. Where we are in the UK, they are very low. But,
I've actually this was from Barbados, and I think it was virtually overhead, so 80 degrees or so at the time.
So if you want to see the planets, you must travel.
Not necessarily, no. But you can travel if you.
Yes, fortunately, Mars is more or less equally placed for a lot of the globe at the moment, and as it's quite close, that is the reason we're doing National Astronomy Week at this time. I think that Agapios has got some images to show us. He's got a video of the moon, so maybe we could go over to Agapios in Cyprus now.
Yep, that's right. I have a short video of the moon that I took a little while ago. Let me just pull it up for you to see. There it is. I hope you can see that all right. So this was taken with actually with my my guide telescope, which is a small secondary telescope that we use when we take long exposure images to correct for the performance of the mount. And I took this a couple hours ago. You can see the moon. It's in the first quarter at the moment, so it appears exactly half in the sky. We can see all along the lunar terminator quite a lot of individual craters. Of course, this is a black and white image. Again, you can spot a lot of craters here. Some of the lunar maria. And I think you can pick out on these bright craters, you can even pick out some these bright streaks, which are the ejecta rays from the asteroid impacts there.
Yes, you certainly can. And this is a sort of view we get through binoculars. So I do encourage people to go out and take a look at the moon through binoculars. And the great thing is that each night you get a slightly different view. That shadow line, the Terminator, as we call it, nothing to do with the movie series, different kind of Terminator, but it does move across the surface of the moon every night. So you see a little bit different revealed each night. And that's a great way to learn the moon, because you don't have to learn it all at once, and you see different craters appearing. And what's more, you see them, as I said earlier on, in sharp relief at this time of the appearance of the moon, with the craters really outlined, and they often look as if they've got really steep mountains. But as we know from the pictures from the Apollo astronauts, the lunar surface is actually quite low and undulating. It's a bit like when you see, say, a hedgerow across a field and under illumination, and it looks, the shadow of it on the ground looks very sharp and as if there are high peaks on it, but in fact it's just a slight undulation. Well, that's great. And Mars, have you got good clear skies where you are still?
Yep, it's still clear, and I'm just finishing up a sequence on Mars to see if we have any. Hang on. See if we have any.
So this is the live view again you've got here.
Yeah, we have the live view, and I'm just gonna do a quick sharpening on one of the videos that I just took while we were showing the moon, and see if we have any more detail to show. Let's just give this a few seconds.
Yeah, well, this is the great thing. This is all live, and we're seeing you do the work as it actually happens. So there's no certainty about how it will turn out here.
Yeah, that's right. So there's the latest sequence that I took, a 1 minute video file. I'm just going to sharpen this a little bit. Yep. I think that looks better than it did before.
Yeah.
And let's try to enlarge this. There we go.
Oh, fantastic. So you can see the area known as Solis Lacus there, and that's great. And one of the interesting things is that people of my age will remember that when we were reading about Mars as kids, we were told that there were canals on Mars, and yet pictures these days don't show any. And then when Mariner 9, which I mentioned earlier on, went to Mars, it showed this great canyon across the Martian surface, which I'm sure you'll be able to point out where it is, the Mariner Valles Marineris. And yet there's no canal there. It just doesn't show up. And it turned out that the reason that people saw those canals, they were purely figments of the imagination, the eye trying to join up dots. And as we've seen, Mars, when you're looking at it through even a large telescope, is all over the place. It's jumping around due to the turbulence of our atmosphere. And that means that you're straining to see the details. And the funny thing is that the first time they were seen wasn't until 1877, when Mars was particularly close to the Earth, and an Italian observer named Schiaparelli saw what he believed were canals, and he called them canali in Italian, which means channels, or nothing, not implying any particular artificial construction. Just as you might refer to that Mariner Valley as a channel. But this got interpreted as canals by the English-speaking world. And so for years and years and years, we believed that there were canals on Mars. The next year, he said that the next time Mars was close, he actually saw them double. And then Percival Lowell over in the States believed that these were really Martian canals. It seemed a reasonable thing. It was not known that there were no people on Mars, that Mars was just a totally barren place, which we now believe it to be. If there is any life on there, it's certainly not in any way responsible for any of the surface features that we can see. And he believed that it was the canals were dug by intelligent people to bring pardon me, water from the polar caps to the parched deserts in the around the equator. But when Mariner 9, well, originally Mariner 4 went to Mars in 1964 and took the first photographs, no canals to be seen. So I'm afraid the idea of the romantic idea of Martians with the green skin and all digging canals frantically to bring the water from the poles has died died back in the 60s. But funny enough, even in the 1950s, science fiction writers such as Arthur C. Clarke and indeed Patrick Moore were writing books which assumed that there was vegetation on Mars. And even Arthur C. Clarke wrote a book called The Sands of Mars, which had creatures on the surface of Mars, kangaroo-like creatures. And that's not all that long ago. And that was the sort of idea that I was brought up with, that there may well be not just vegetation, but possibly even creatures on Mars. And that was the great Arthur C. Clarke who predicted that. And as you can see from the picture there of Mars taken just a few minutes ago by Agapios, I'm afraid no canals, and we believe no life as well. Let's move back to David Arditi back in London and see, thanks Agapios, and see what he's got for us. David, how's things there?
Things here are that I have taken, as Agapios did, a video of Mars, and I have processed it, and the processed result is here. Obviously, it's more or less the same as his, and we can see again the Solis Lacus there, the tiny South Polar Cap, these and down there there's Olympus Mons, and it's near the terminator, so you can see it just about. It's, if you're, depending on how good the image you're receiving is, you may be able to see it. It's casting a shadow towards the terminator.
Yes, we can see that, yeah.
And Olympus Mons is 20 miles high. It's, I forget, either 100 or 200 miles in diameter, something like that. Huge diameter. It's so big that if you were standing at the base of it, you wouldn't be able to see the summit of it. It would just be disappearing over your horizon. It's just a big, like a big upturned plate shape with a crater at the top. And there are really 4 really big volcanoes on Mars, the others being the 3 Tarsis volcanoes on the Tarsis bulge. So it's Mars, of course, because it's got lower gravity than the Earth, its mountings can be bigger in relation to the size of the planet because there's less force to pull them back down. And that's in general what you find with objects in the universe. The bigger they are, the more spherical they have to be because of gravity, but the smaller objects are relatively irregular, and the smaller objects than Mars, such as the asteroids and small moons of the solar system, they can be very irregular in shape. But Mars is pretty irregular, and you look at different parts of it, and there's these huge differences, like the Mariner Valley, which is an order of magnitude or 2 orders of magnitude bigger than our Grand Canyon. So that's a great gash across the surface, and that's just that's this area here, just north of the Solis Lacus. And so because it's not a very big world, you can get these huge irregularities in Mars. We were talking about Percival Lowell. Percival Lowell was actually completely nuts. So he did think there were canals on Mars, but he also claimed to see canals on Venus as well. And we now know that Venus is covered with a thick atmosphere, and indeed it was known then that it was covered with a thick atmosphere, and you can't see through the atmosphere at all. So really he was seeing things. And the observations that he produced were maps where he got his team at the Lowell Observatory at Mars Hill in Arizona. He got his team to draw a new canal every time they suspected they had seen a canal. So the globes just got full up with these canals, because every night they would look and see a different one and draw a different thing. And anybody with scientific training knows that's not how you do science. You have to see them all at once. Obviously, you should be able to see them all at once on the best night. So Lowell's methods were completely unscientific. On the good side, however, he did initiate the program to look for the outermost planet, for the 9th planet, which did eventually discover Pluto. So that is to his credit.
You've actually answered one of the questions that we had earlier on I forget who posed it, but it was the question of whether Mars has volcanoes. But the question is, are they still active?
They're not active, and they haven't been active for a long time. I don't know what the best evidence is now, but they were active at a much earlier era of Mars's life cycle, so probably hundreds of millions of years ago at least.
Now, looking at that image there of Mars, more or less a live image as it was just a short while ago, what actually causes the dark markings to shift in shape and position? Because when I was young, all the books said that there is that is one of the reasons we think that the dark markings are caused by vegetation on Mars, because they do change in appearance and colour. What's the latest thinking on that?
We now think it's just dust being blown around and revealing darker colour rocks. We think that dust blows away. It generally blows from the South Pole outwards, as because during the southern summer you get winds blowing from the South Pole outwards, and we believe that clears away the dust from the southern hemisphere, so that results in the predominance of the dark albedo features in the southern hemisphere. So it's no, it doesn't. The features, I think, were interpreted as being green. I think that's another optical illusion, like the illusion of small points merging into canal-like features, which is one optical illusion. I think another optical illusion of Mars is the color illusion, because it's this bright orange or red color, and we see it through a telescope as quite a small spot in a big black background. The contrasting areas, the darker albedo features, we see them as green by contrast, because that's what the human eye does. It adjusts, and when you've got a generally red light in your eye, it interprets the areas that are not so red as being the other end of the spectrum, greenish or bluish. But we can see in these images that genuinely they're not green. And so I think that the idea of vegetation partly came from that. It came from the color illusion. So there are many things to be aware of when observing with your eye. The eye does not necessarily tell the truth.
Indeed. It occurs to me, incidentally, we're talking about encouraging people to go out and look at the sky. One of the reasons we're doing National Astronomy Week now is because Mars is high, and the original plan, when we started planning it 2 years ago, was to get the local astronomical societies around the country to have live observing sessions. And I thought it would be a good opportunity, David, for you and I to mention that both of us are members of the West of London Astronomical Society, and had it been normal times, we would have been freezing out in the wilds of Ruislip showing people the sky at this very moment. But as it is, we're doing it to a larger audience over the whole country. But if you want to join a local society, in London, we've got the West of London, we've got others around London as well. There's one down in Croydon, one over in Ewell. There are quite a few around London. Check out the website of the Federation of Astronomical Societies, and that will tell you where your local society is. The FAS is one of the sponsors of National Astronomy Week, and so it's a good point to mention that if you want to go out and find the objects in the sky, when we can return to showing people the sky, then Federation of Astronomical Societies website is the one to look for. And I might also plug my own, the society of which I'm vice president. That is the Society for Popular Astronomy. And so if you want to start astronomy, well, we're there for you, and it's www.popastro.com. Do look at our website. Well, that's the plugs out of the way. What have you got on that shot there, David?
That is Messier 2. This is more or less a live shot. It was taken a few minutes ago. It's a 1 minute exposure of a globular cluster taken with an 11-inch telescope, which has an interesting optical arrangement. It's got the camera at the front of the telescope, so it gives a mirror reversed image. But having the camera at the front of the telescope allows it to have a short focal length, so it can get the larger deep sky objects in the view, although this isn't a particularly large object. This is a globular cluster, and the globular clusters are great populations of stars which are on the outer edges of our galaxy. And Messier 2 is actually 38,000 light years away. So it's a long way away. It's nothing like as far away as the Andromeda Galaxy, which is 2 million light years away. But the globular clusters, it's not really known what they are. They are groups of many thousands of stars clustered together, very close together, held together by gravitational attraction. One theory is that they are the cores of galaxies, where the galaxy has been eaten up by the Milky Way galaxy, and the spiral arms have been stripped off, and you just end up with a core of densely packed stars. And that theory is supported by the fact that the spectra, the light distribution in those stars, it tends to be quite red, although it doesn't look like it here. It tends to be reddish. They tend to be old stars, and some of them seem to be some of the older stars in the universe. So it seems likely that they're the remnants of very old galaxies, and they're scattered round the Milky Way galaxy in a kind of a halo. And they were used by Harlow Shapley in the 1920s, using the 100-inch telescope, which was on Mount Wilson, then the largest telescope in the world, to get an estimate of the size of the Milky Way. And that was really one of the first accurate determinations of the scale of the universe, and then followed on quite quickly the determination by Hubble of the distance to the Andromeda Galaxy and so forth. So the globular clusters were an important staging post in measuring the size of the universe, stepping out from measuring the distances to stars, then measuring the distances to the globular clusters, and then measuring the distances to the external galaxies. Now, this isn't a very good image. You can see it looks green. You may wonder why the whole sky is green. Well, it is green here in London. There's a lot of light pollution, so that background sky is green. And if I'd taken this in a dark place, you wouldn't have had that green background. But when I process images like this, I can subtract out that background sky and end up with an almost black background. And then you would take several images like this and you would combine them together.
And when we return to normal observing, and you go to all these observation sessions I've been telling you about, then you would be able to see an object like that with through large telescopes for yourself. And so that's something to look forward to. Let me just repeat that if you keep an eye on Jupiter and Saturn down on the low in the western horizon, and notice how they're getting closer and closer together. Jupiter is closing in on Saturn. As I said, it moves faster through the sky than Saturn does. And by the end of the year, on December the 21st, the two planets will be really close. Another planet that's in the sky at the moment is the planet Uranus. And if you want to know how to find it with your binoculars, look on the National Astronomy, look on the Society for Popular Astronomy website, SPA website, that's popastro.com. And you will find on the homepage there is a video showing you how to find the planet Uranus. Well, Agapios in Cyclos knows how to find it, and he's found it through his telescope. So let's go to him for a final look at something in the sky.
I'm not sure he has found it yet. He can tell us.
I'll be needing a couple of minutes and I'll be there for you.
Okay, well, as I say, we can find it in the sky. Now, Uranus is interesting because it was actually the very first National Astronomy Week was held in 1981 to celebrate the anniversary, the 200th anniversary of the discovery of Uranus, the planet Uranus. It's one of the planets you can't see easily with the naked eye. It's just a very tiny speck. If you've got really good eyes and good dark skies, you could just about see it. But it had not been noticed until William Herschel discovered it in 1781 from the city of Bath. He had his amateur-made telescope, a small telescope, much smaller than the ones we're using, from the centre of Bath in New King Street, and he discovered this star, which looked like a star moving through the sky. At first he thought it was a comet, and then he realized that it was actually a new planet, the first planet ever to be discovered. So we've got a particular fondness for the planet Uranus in the UK because it was discovered from the streets of a city in England. So that's a wonderful start to the series of National Astronomy Weeks we've done. And we held National Astronomy Week, the first one in 1981, to celebrate that. And there was one also in 2009 we held to celebrate the first view of the moon through a telescope which was actually made by Thomas Harriot from Sion House in Middlesex. And we often don't get the credit for discovering things in the sky from the UK, but those two major objects were observed first, the Uranus and the moon through a telescope from the UK. And so Uranus has got a special place in our heart, and it's a very distant world. It's way out in the frozen wastes beyond Saturn, and so it's very difficult to spot. But if you follow the guide on the SBA webpage, you can actually find it with binoculars, just as a little point of light, and as you watch it from week to week, you will see it moving through the sky. So although it just appears as a point of light through a telescope of the size that Agapios has got there, a 9.5-inch telescope, we will be able to see a bit more detail on it. How's it going now?
I'll tell you another anecdote, Robin, just to waste a bit of time. I remember the 1981 National Astronomy Week, and I was only 15 at the time, and I put a poster in my window saying, does anybody want to look through a telescope? So doing a little bit of independent public outreach there. But I only ever got one reply back. And apparently, according to my mother, somebody phoned up and said, does he do the readings? So I think they were confusing astronomy with astrology, as so often.
Well, I'll tell you what we'll do. We've got actually all lined up, all the people. We'll come to Agapios in another live view just in a minute when he's got it up. But we've got all the people who were planning National Astronomy Week, and I just mentioned the origin of the week. We've got us all ready to give a wave. And so can I ask everybody to switch on their cameras, and Lucinda, who's been patiently acting as our director through the whole of National Astronomy Week, has been is there as well, and it's been a wonderful opportunity for us to show the sky to everybody. So let me just introduce, I can't see everybody. Yeah, we've got Brendan Blake, who's been helping with the computer side, Anne Mills of the South Downs Planetarium, got Natalie Corhonen, who is our coordinator, and she is actually in New Hampshire at the moment. She started out in this country. We've never actually met her live. We've only ever seen her as a face smiling at us through Zoom. Sharon Leverment, who is in the running Planetaria and the Explore. Unmute yourself, Sharon, and tell us what you do, because you've done a huge amount for us over the week.
Oh, I work with science centres and planetarium domes, so I'm lucky enough to be plugged into the most amazing people, like the educators and the amazing speakers. So I've been working with Lucinda, putting the right speakers in the right places to dazzle us all during during National Astronomy Week for the school sessions and these evening sessions as well. So that's been my role.
And also in the background has been Robert Massey, who is from the Royal Astronomical Society and has been helping out with lots of things behind the scenes, and he's hosted a session as well. Just say a word or two, Robert.
Yeah, well, it's been a great pleasure to do this. Actually, I think more credit deserves to go to Lucinda, who's basically been grafting for 9-10 solid days over National Astronomy Week, and quite a long time before that as well. So, you know, we should absolutely give applause and plaudits to Lucinda, who, by the way, I'm mandating takes some time off in the coming days.
Right, and Peter Bosley is not on screen, but she is a representative from the British Astronomical Association. NAW has been sponsored in part by all these societies, and well, will there be another one? We don't know yet. Can we get Peter back on screen? Just to give us a wave.
I think it's someone is doing something. Yes, there I am.
Yeah, there you are. Right.
Hello.
Great to see everybody. So let's all give, I think if we can just go for a gallery view of everybody. Can we do that, Lucinda? Lucinda's muted. For once, Lucinda's muted.
You're still on mute.
Yeah.
We're going to get that t-shirt printed right away, Anne. But Robin, we've been on gallery view for quite a long time already.
Oh, right. I've just seen everybody's face. I'm not seeing the final view. That's great. Okay, well, let's just give a last wave. And then after that, if we can go back to Agapios and we can play ourselves out with a live view, hopefully. Bye, everybody.
Wonderful. Bye.
See you next time, whenever that may be.
Thank you, everyone. Thank you, practical astronomers. You guys have been awesome.
Thank you.
Thank you, Agapios.
Right, so Agapios, can you help out now with a live view? There it is. That little blue dot. People call the little blue dot the planet Earth, but that's the planet Uranus, another watery world. It's got a lot of water on it, but the blue color is due to methane in the atmosphere, and that is the most distant world that we've shown this time. Planet Neptune is a bit farther away, but that is a very tiny dot. So that's a good rounding off to National Astronomy Week with a view of the planet that started it all off. So thanks to everybody, and see you next time, whenever that may be. Goodbye.
Bye-bye.
Bye.